All right, we go on. A community of 8 people to be formed by 5 teachers. So we have how many in total? 5, 4, 3. We have 12 teachers. We have 12 persons, and we need to pick 8%. Okay. Now we look at the first question. All 4 doctors must be in the community. So all the doctors must be in. So we have 4 doctors in total, and we need all. So 4C4, 4C4. Okay. So once you have taken the doctors, how many are the others? How many others left? You have 5 more teachers and 3 more police. So you have 8 others left. You have 8 others left, and out of these 8, you need how many more? Because total you need 8. You have 4 here. So how many more do you need? 4 more. So XC4. So that is 4 teachers and 4 others now. 4 teachers and 4 others. 4 teachers and 4 others. So 4C4 times XC4. What do you get? You should get 70. Okay, 4C4 times XC4. Okay, now the next question is at least 2 teachers must be in the committee. At least 2, it can be 2, it can be 3, it can be 4, it can be 5. Can it be 6? No, maximum 5, because you only have 5 teachers. So it could be 2 teachers, 3 teachers, 4 teachers, 5 teachers maximum. But if you go for 2 teachers, is it enough for the committee? No, you need 8 in total. You need 6 more. And that 6 more cannot be teachers, it should be non-teachers. I call it as 6 others, 5 others, 4 others, and 3 others. Okay, 2 teachers. How do I write this? How many teachers in total? 5 teachers in total, and you need 2. So 5C2, 5C3, 5C4, 5C5. Okay, how many others do we have? What do I mean by others? Others meaning excluding the teachers, because this is all teachers, this is all others. So if you're excluding the teachers, you have 4 plus 3, 4 doctors and 3 police, 7 others. So you go for 7, 7C what? You need 6, right? So it is 7C6, 7C5, 7C4, 7C3. Figure out the value on your own. And once you add up, the answer should be 490. Once you add up, the answer should be 490. Okay, you can check it on later on. And then, okay, see, this kind of question again. NP5. So it's not NC, NPR. So you're going to use the NPR formula. This is the NPR formula, n factorial over n minus r factorial. So NP5, n factorial over n minus r factorial equals to 6 times n factorial over n, this is my n, minus r factorial. Okay, what can we do? This is very simple actually. N minus 5 factorial, this is also n minus 5 factorial. Same thing, same level as part of the denominator. You can cut, you can cut. Once you cut, then you have n factorial equals to 6 times n minus 1 factorial. So look at these two again. Always change the one with a bigger or greater value. Which one is greater? N factorial is greater or n minus 1 factorial is greater? N factorial is greater. So you're going to change this one. So we're going to change with n followed by the next term, u minus 1. So once you minus 1, that is n minus 1. Do we stop here? Do we put a factorial here and stop? Or do we go on with n minus 2? We stop here because we have n minus 1 factorial on the right. And I want to cancel it off later on. So you stop here. So you stop here with n minus 1 factorial. You put it here. Okay, then you have n6 minus n factorial. And then you cut this off, n equals 6. Accepted, since this is not a negative value. Okay, so n is 6. Okay, we go on the next questions. Okay, let's do this first. A 6 collector password. So we have we need 6 lah. We need 6 collector. Out of 8, because we have 5 digits and 3 symbol. You have 8 collectors and you need 6 of them. Find the number of their no restrictions. Okay, you need 6 and you have 8. So I have 8 collectors and I'm going to pick just 6, 8P6. So you should have 20160, right? Okay, the next one. The password start with a digit, finish with a digit. So how many digits do we have? We have 5 digits. So we have 5 digits here and you only need 1, 5P1. So the first and the last, right? The first slot must be a digit and the last slot must be a digit. Start and finish with a digit. So 5P1, so you have one digit filled. So you only have 4 digits left, not 5 anymore. So you have 4 digits left and you're going to pick 1, 4P1. And then, because total you have 8. Now 2 slot has been filled. So you have 6 collectors left. Regardless it is a digit or symbol. You have 6 left. So out of these 6, you're going to pick 4 to be arranged. 5P1, 6P4, 4P1. What is your answer? 7,200. Okay, the next one. The password start with 3 symbol. Oh, okay, 3 symbol. Meaning these 3 must be symbol. How many symbols we have? Oh, we are just 3. Right? You have only 3 and you need to be filled for 3 slot. So 3P3 lah, right? 3P3. So all these 3 must be a symbol. You have 3 and you need to fill in 3 slots. So 3P3. Okay, 3P3, then what is left is just the digits. You have 5 digits and you need 3. So 3P3 times 5P3, you should get 360. Okay, alright. Another NPR and CR questions. Selected. So the moment I saw the word selected, no arrange, I know it's C lah. Okay, this is a 5 object selected for M object, NC5. NC5 is 6 times, meaning equals to 6 multiplied with 4 objects selected from N minus 1. That will be N minus 1 C4. You just have to understand, interpret the equation from the statement. NC5 equals 6 times NC1 C4. We change it to the formula. Remember the formula that we use? C, right? N factorial over N minus R factorial, R factorial. So we use this one. N factorial over N minus 5, meaning N minus R factorial equals to 6 times N, this is my N factorial over N, this is my N, minus R factorial. Why this is so similar to the previous questions? So if you look at this, this is N minus 5 factorial. This is also N minus 5 factorial. You cut it off, or slightly different, huh? And then you look at this one, N factorial and N minus 1 factorial. Which one is greater? N, right? N is greater. So we change this one. We change this one to N, followed by the next term, N minus 1, and we put a stop here. We stop here because there's an N minus 1 factorial on the right, so that we can cut. Okay? And then 5 factorial, it is 120. Oh, not times 6, it should be equal here, equal 6 times N minus 1 factorial, because that's 1 for the, it's 1 for the denominator, doesn't matter. So we cut this, we cut this. So eventually you have N over 120 equals to 6. Oh, something is wrong. Oh, I forgot the R factorial. Yeah, I forgot the R factorial. I wonder, it looks so weird. Okay, there's a R factorial here. The R should be 4 factorial. So that should be a 4 factorial here. That is 24, right? Okay, it makes more sense. And then I times 5 to this, I times 5 to this. The denominator is the same, 120 cancel, so N is 30. N is 30. Just now I forgot to include the R factorial. which is the 4, no? Which is the 4. This is my R. All right, so we go on. Okay, we need 5 people to be chosen out of 10 persons. No restriction. So 10C5. Selecting people is always C lah, if you're not going to arrange it. 252. At least 2 men are chosen. Okay lah. At least 2 men, so it could be 2 men, 3 men, up to 4 men, because there's only 4 men in total. 2 or 3 or 4. Okay lah. If you need 2 men, meaning you need another others. How many others do you need to be 5 people? 3 more. 3 more others, 2 more others, and 1 others. 2 men. So I have 4 men in total. I need 2. 4C2, 4C3, 4C4. Others. Others referring to women and 2 children. So I have 6 in total. Out of 6, I need 3 more. So 6C3, 6C2, and 6C1. So after you calculate the answer, for each, you add up, the final answer should be 186. Okay, there's another question. If at least 1 man, 1 woman, and 1 child are chosen, there are a lot of a lot of working, if you want to write. Because 1 man, it can be 1 man, 2 women, and then 2 child to make it 5. Or it can be 3 men, 1 woman, and 1 child. A lot to list. So when there's a lot to list, there will be a shortcut. Okay, think of a shortcut. The shortcut is the one with no restrictions. The number of ways of selecting 5 people out of 10 with no restriction minus the impossible case. Impossible case meaning the case that did not fulfill the criteria of 1 man, 1 woman, or 1 child. What are the criteria that does not fulfill? At least 1 man. The impossible case, the opposite case? Yeah, that's right. So it is no restriction minus no man, because no man you cannot be at least 1. 0 man, 0 man. Or it could be no woman, 0 woman, or it could be no child. Okay, no restriction minus the impossible case. So no restrictions, it will be 10C5, right? No restriction with 10C5. Impossible case, we think of no man first. Impossible case, we think of no man. Okay, what happened if there's no man? If 0 man, 0 man, then you need how many others? 5 others. If it's 0 woman, then you need 5 others. Same. You have 0 child, you need 5 others. So, okay, look at this one. If 0 man, who are the others? If 0 man, the others would be 4 women and 2 children. Right? So it is just 6, because 4 women and 2 children, 6C5 for no man. And then for no woman, 4 men and 2 children. So also 6C5, because you need 5 others. 4 men and 2 children are the others. And the last one is no children. No children meaning 4 men and 4 women. It's not 6 anymore, but 8. The others are the men and women. XC5, you need 5. So figure out the answer here. 6C5, 6C5, and XC5, I think you will get 68. 10C5, you will get 252. So you get the one without restriction minus the opposite or impossible case. And the answer should be the number of ways of arranging at least 1 man and at least 1 woman and at least 1 children. 184. This is the so-called as a shortcut. Because if you list out all the case, I think you have a lot to list. At least 1 man, 1 woman, and 1 child. Okay, see whether you like this method or not. Alright, then any more? Yeah. A 5-digit number, 5-digit number, 1, 2, 3, 4, 5, to be made using 1, 2, 3, 4, 5, 6, 7, 7 digits. So find how many 5-digit number are even. First criteria, it has to be even. So this one has to be even. The last lot, and greater than 50,000. This one have to be greater than 50,000. Okay, it has to be even, then it can be 0, 4, or 6. So I put in, it could be 0, or 4, or 6. Greater than 50,000, it can be 5, 6, 7, or 9. It can be 5, 6, 7, or 9. So is there any crashes? Yeah, there are crashes. The crashes are 6. Okay, 6 only. So we take it out. So we take out this, we take out which one? I like to take out this one. Okay, so I take out this one, 5, 7, 9. You keep this one. This one can be kept. But you take out, then you have to put it in another case. So you can put 6 here. If you put a 6 here, can you still put 0, 4, 6 here? No. It can be only 0 and 4. Okay, if it starts with 5, you can go for 0, 4, 6. If you start with 7, the last digit can be 0, 4, 6. If you start with 9, the last digit can be 0, 4, 6. But if you start with 6 at the first digit, the last digit can be only 0 and 4, because 6 has been used as the first digits. So this is 3P1. 3P1. We have 1, 2, 3, 4, 5, 6, 7. We have 7 in total, minus 1, minus 1. So we have 5 more left, and you're going to pick 3 to be filled. Okay, 1P1, 1, this is 2, 2P1, and same thing, 5P3. $540, 120. The final answer should be 660. Okay, all right. Is it the last question? Yeah, this is the last questions. Okay, another one with a statement. Make sure you understand the number of combination NCR, the number of combinations of an object taken for, meaning NC4, is equal to 6 times, the number of combination of n object taken to NC2. NC2. Calculate the value of n. Remind you again, if you forgot the NCR formula, NCR formula would be the same as this. Alright, so we will have n factorial over n minus r factorial equals to 6 times n factorial over n minus 2 factorial r factorial. Let me check again. The number of combination n object taken at 4 is equal to 6 times because it's 12. Okay, everything is correct, right? Okay, you can cut this off. You can cut this off. It's gone. These two, which one is greater value? n minus 4 is greater or n minus 2? n minus 2. That's right. So we change this one. Change this one. So this one, I bring it up. So 6 on top. And then n minus 2. The next term, n minus 3. Do I put here and stop here? No, you don't stop here because it's n minus 4 factorial on the left hand side. Make sure you turn it to the same kind of thing. So you can cut it off. So you continue with n minus 4. Then only you put a factorial. Then you stop here. Huh? So you're changing n minus 2 factorial into this. 2 factorial, it is 2. And you can cut it off. Become 3. Here is 1 on top. N minus 4 factorial over multiply with 24. Okay, then you cut. You cut n minus 4 factorial, you cut n minus 4 factorial. In the end, you have 1 over 24 equals to 3 over n minus 2 n minus 3. Okay, I do a multiply, cross multiplications, 72. This is a quadratic equation. N squared minus 5n minus 66. Use your calculator. I think it should be quite beautiful. So you can use cross factorizations. Should be 11 or negative 6. N minus 11 n plus 6 as your working step M1 method 1. And you are going to reject the negative value. I told you why just now. So the final answer is just 11. Okay, that's all for now. Thank you.